Hello GATE aspirants, welcome to part 1 of GATE Mathematical Physics series. Question number 1. Consider an antisymmetric tensor Pij with indices I and j running from 1 to 5, the number of independent components of the tensor, and that number is given by this n into n minus 1 upon 2. So here n is 5, so this will be 5 into 4 by 2, that is 10. This is a tensor of order 2, so it has two indices, so it will be a matrix. So if tensor is of order 1, then it will be a vector. If it is of order 2, then it will be a matrix, and it will be a matrix which is 5 cross 5, and it is an antisymmetric one. That means these diagonal elements will always be 0, and all these elements in the upper triangle, that they will have negative sign on this side. So for antisymmetric tensor or antisymmetric matrix, we have this matrix equal to minus of M transpose. So that will be antisymmetric matrix. So only these components we require. So that only we have to count. So this will be 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So this will be 10. So independent components are 10. So here option B is correct. For symmetric one, we have n into n plus 1 by 2. So this will be for symmetric tensor. Next question. The value of the integral Ez sin z upon z square dz, where contour C is the unit circle, z minus 2 is equal to 1. So this is the circle with radius 1. This radius is 1 and center is at 2. So this is 0, then 1 and then 2. So center will be here and its radius is 1. So this will be the circle. This will be the contour that we are dealing with. Now function is f of z is equal to e raised to z sin z upon z square. Now this function will be analytical if the singularities are outside this curve. So let us find out singular points first. So singular point will be when denominator is 0. So z square is 0, that means z is equal to 0. So z is equal to 0. So this function f of z, it has a pole of order 2. Pole of order 2 at z is equal to 0, and it lies outside this curve, which lies outside the curve. That means this function is analytic. And if the function is analytic, then this integral f of z dz, it will be 0 by Cauchy's integral theorem. So option D is correct. This will be 0 because the function is analytic. Next question. The eigenvalues of this matrix are. This is the matrix given to us. Now let us first find out trace of this matrix. So trace of this matrix is 2 plus 2 plus 1, that is 5, which is also equal to summation over lambda I. So let us calculate summation over lambda I in each case. Here it is 5, here it will be minus 7, here it will be 5, and here it will be minus 5 plus 1 plus 1. This will be minus 3. So in these two options we are getting 5. So let us check for determinant as well. Determinant of this matrix, it will be 2 into 2 minus 3 into this will be 0. So this determinant, it will be, okay, so we have 3 into 1. So determinant will be 4 minus 9, that is minus 5. So determinant is this will be equal to multiplication of lambda values. So this multiplication will be 5 into 2 into minus 2, that will be minus 20, and here 5 into 1 into minus 1, this will be minus 5. So option C is correct, because 5 plus 1 plus minus 1 is equal to 5, and 5 into 1 into minus 1 is equal to minus 5. So then it is matching. So option C is correct. Next question. If f of x is 0 for x less than 3 and x minus 3 for x greater than or equal to 3, that the Laplace transform for f of x is. Now Laplace transform of any function f of x is equal to integration from 0 to infinity e raised to minus sx into that function dx. Now this function is 0 for x less than 3. So 0 to 3 it will be 0. So 0 to 3 e raised to minus sx 0 into dx plus 3 to infinity we have x minus 3 into e raised to minus sx dx. This will be 0. So integration of this we can apply UV rule here. So first x minus 3 e raised to minus sx upon minus s minus e raised to minus sx minus s square, and this derivative of this will be 0, and it is going from 3 to infinity. So when we put here infinity, then both these terms will be 0 because e raised to minus infinity is 0, and when we put 3 here, so this first term will be 0 and second term will be minus minus, it will become plus, it will be minus s into 3 upon minus s square, that is s square. So this will be s raised to minus 2 e raised to minus 3s. So here option D is correct. Next question. For the complex function f of z is equal to e raised to minus z minus root z minus e raised to minus root z upon sine root of z, which of the following statement is correct? So this is the function. We can multiply and divide by 2. So this will be 2 upon sine of root z e raised to root z minus e raised to minus root z upon 2. Now this function is sine hyperbolic function. So this is equal to 2 into sine hyperbolic of root z upon sine of root z. Now singular point we have to find. For singular point, this denominator will be 0. So that means z is equal to 0. That is our singular point. And if we put singular point z is equal to 0 here, then this will be of 0 upon 0 form. So here we have our singular point z is equal to 0. Now we have to check whether it is a pole of order 1, removable singularity, essential singularity, or branch point. That we have to check. So for that, take limit z tending to 0 of this function. This is our function sine h root z upon sine root z. But it is giving us 0 by 0. So we can use L'Hospital's rule. We will use L'Hospital's rule here. So we have 2 into sine h, so that will be cos hyperbolic root of z, sine, then again it will become cos of root z. Then we can put here also we have root of z here, no? So into we have to multiply 2 into root z. Here also 1 upon 2 into root z. This will cancel out. Now if we put z is equal to 0, then these terms will become 1 and we'll get 2 here. Now this is finite. So if we are getting finite value of limit f of z, then this is a removable singular point. So this is a removable singular point. So option C is correct. Next question. The solution of the differential equation for y of t d2y by dt square minus y is equal to 2 cos h t subject to the initial conditions y of 0 is 0, dy by dt at t is equal to 0 is 0 is. So for this we have this function. This can be written as d square minus 1 into y. Its auxiliary equation will be this, is equal to 0. That means d square is equal to 1. That means d is equal to plus minus 1. So the function y of t, it will be c1 e raised to t plus c2 e raised to minus t. This will be the function. Now we have to find particular integral at as well. So for particular interval, this is our differential equation 1 upon d square minus 1 and function is 2 cos h t. So this will be equal to this 2 cos t, we can write it as e raised to t plus e raised to minus t upon 2. So this will be d square minus 1, and we have e raised to t plus e raised to minus t upon 2, and this 2 that will cancel out. Now if we have a function some function e raised to x like that, and if this is our function f of d and then it is operated on e raised to ax, then this is equal to 1 upon f of a into e raised to ax. And if this f of a is equal to 0, if this is equal to 0, then we have to take derivative on both sides. So this will become 1 upon f of d, this left hand side, it will be equal to, take this x outside, 1 upon f dash of a into e raised to x. This is the formula that we have to use it here. Now if I put here a is 1 and here a is minus 1, so its square will be 1 and 1 minus 1 is 0. So it is coming out to be 0. That means this f of a is 0. So we have to use this second one. So take derivative. This will be 1 upon 2d, that is derivative. And this t here operated on e of t. Similarly here as well we will have minus of t, because here it is minus t, and then 1 upon 2d into e raised to minus t. Here it will be plus only, then we will substitute it. So this is the case. Now we can substitute it here. So at the place of d we will substitute 1. So this will be t into 1 upon 2 into 1 into e raised to t plus t into 2 upon minus 1 into e raised to minus t. So this particular integral, it will be t by 2, and then we have this e raised to t minus e raised to minus t. So final equation is this, c1 e raised to t plus c2 e raised to minus t plus this. So addition of these two will give us final equation. Now we have to use these initial conditions, and initial condition is y of 0 is 0. So final condition, y is equal to c1 e raised to t plus c2 e raised to minus t plus t by 2. Then we have e raised to t minus e raised to minus t. Then y of 0 is equal to 0. That means c will be equal to c1 plus c2. Now second derivative of this will be c1 e raised to t minus c2 e raised to minus t plus t by 2 into derivative of this e raised to t plus e raised to minus t, and plus half into e raised to t minus e raised to minus t. This will be its derivative, and y dash of 0 is equal to 0 again. So this will be c1 minus c2. So c1 plus c2 is 0, c1 minus c2 is 0. That means c1 is equal to c2 is equal to 0. So this first part of the solution is 0 only. So finally y is equal to, you'll get t by 2 into e raised to t minus e raised to minus t, which is equal to t into sine hyperbolic of t. That will be the final function. So option D is correct here. Next question. Given the recurrence relation for the legendary polynomials, which of the following integrals has a non-zero value? Now here, since we know legendary polynomials, like p00 is 1, then p1x. So p1x is equal to x, then p2x is equal to half of 3x square minus 1, then P3x is 1 by 2 5x cube minus 3x square. P4x is equal to 1 by 8 into 35x raised to 4 minus 30x square plus 3 and so on. Now there is one pattern. This P of 0, this function is even function. Then this function is odd function. Then we have even function, odd function, even function, odd function and so on. So alternately these functions will be even, odd, even, odd. So we can use that fact here. Now for the first case, this is x square. That means this function is even function. Now we will assume that Pn of x it is even function. This we are going to assume. So let us assume that Pn of x is even. So this is even, even. Now n plus 1, that means next polynomial, it will be odd definitely. So even, even, odd. That means this will be 0 because this interval is from minus 1 to plus 1. So in that interval, if we are having a odd function, then this integral is going to give us 0 value. For the second case, we have odd, x is odd because power is 1. P1 of x is even and n plus 2 it will be even. But since it is an odd function, it will be 0. Then x is odd, then P1 of x is even into even. So again it will be 0. Now x square is even, Pn of x is even and Pn plus 2. So it will also be even. So this will be having non-zero value. So option D is correct. So this way you can directly say that option D can be D will be correct. Or else you can use orthonormality condition, which is also we have used here. That is Pmx into Pnx dx is equal to 2 upon 2n plus 1 into delta mn. This is orthonormality condition. So you can use this and use this relation. We have this relation 2n plus 1 x into Pnx is equal to n plus 1 into Pn plus 1 into x plus n into Pn minus 1 into x. Now we can change this variable from n to n plus 1. I will do this calculation for first case only. So change n to n plus 1. So this will be 2n plus 3 into x, then Pn plus 1 into x is equal to n plus 1. So this will be n plus 2 Pn plus 2 into x. At every place where there is n, change it to n plus 1. So n plus 1 Pn x. So this will be the case. Now in the first integral, it is multiplication of Pnx into Pn plus 1x. So we can then, and also x square is there. So we can multiply left hand side of this equation, let this be equation 1 and equation 2. So this function will be 2n plus 1 into 2n plus 3 into x square into we have Pnx, Pn plus 1 into x. This will be the left hand side. And on the right hand side, we have multiplication of two binomials. Now for these two binomials, see here, we have n plus 1. N plus 1 into n plus 2, it will be 0. N plus 1 into n, it will be 0. Again, Pn minus 1 into n plus 2 will be 0. And this will also be 0. So you can see for all these combinations, we are getting right hand side to be equal to 0. Similarly, you can do this calculation for B, C and D. And then also you will get that for on the D option, you will get non-zero integral value. So these were all the questions from GATE 2010 paper. If you like this video, please give it a thumbs up and subscribe to my channel for more videos. Keep learning.